So this is one of the hardest question in or hardest topic in organic chemistry NMR, and this is the question sent by one of my student. So let's understand this question. But before that, I would like you to understand a bit of basics of NMR, and then we'll go through this question. The first thing I want you to understand is what is a peak. Peak is just a different hydrogen environment, and just look at the example, and it should make sense to you. That CH3CO CH2OH. So if you just display the formula of this compound, you will have carbon, carbon, and OH attached to it, and you have got hydrogen, hydrogen, and hydrogen, hydrogen, and hydrogen. So you can clearly see that there are three hydrogen. This one, and this one. They all have got neighbor, this carbon atom neighbor. So all of these three are in the same environment. So there will be three peaks. So one peak by these hydrogen atoms, another peak by these hydrogen atoms, and one peak by this hydrogen atom. So three peaks because there are three different environment of hydrogen. Okay, what is hydrogen environment? It's just the chemical surrounding, which we already have discussed. So what's next to them? That's what their surrounding is. Okay, so you can read this slide if you want to pause and go over it. Then what is integration ratio? Integration ratio is slightly tricky part, but it's just the area which is under the peak, and it gives you the relative number of hydrogen atom. I will give you an example in a minute with the next part, which is what is a splitting pattern. Splitting pattern is, again, now I'm just going to talk through about this, and I will slow down myself, and you listen to this very carefully. So splitting shows neighboring hydrogen, and you use n+1 rule. Yeah. For example, if I show you CH3, CH2, and OH, so these three hydrogen atom will give you one peak, this will give you another peak, and this will give you another peak. So three environment, three peaks we have. Okay, now the area or integration ratio, meaning how many hydrogen atoms are there in that environment on this carbon. So there are three. So the area should be equivalent to three hydrogen atoms. It should show you that there are three hydrogen, or the integration ratio will be given to you, might be given to you as well. Now the next peak shows you only two hydrogens. So I will have to make this peak a little smaller, because the area should be a little less to integrate two hydrogen atoms. The last one, which is one hydrogen atom, it has to be, as you are correctly thinking, very corresponding to one hydrogen atom, that much area. Okay, now let's talk about splitting. This peak is going to be split by the neighbor according to the n+1 rule. So here n+1, meaning this is going to split into three triplet. So, but the area, please make sure you make it equivalent to this much area. Like, just see if the area in these peak is just matching with the area you had for three hydrogen atoms. Okay, now this one will be split by this hydrogen atoms, and there are three, so it will be quadrate. So n+1. So therefore this peak will be split up into four different peaks, but then the area you have to make sure it remains this much amount. So 1, 2, 3, 4, like this. Yeah, matching with the area of the two hydrogen atoms. Hydrogen doesn't cause any split, so that's why for n+1 we didn't use the hydrogen from OH, because normally OH and NH do not cause any split. Neither they are going to, their peak will not be split. Neither they cause anybody else's peak to split as well. So they will found as one. Okay, so this is what splitting means. Now let's talk about this question. Question says compound. I'm just going to read it. Compound VX, VW, and Y are isomers and have the molecular formula of this much. Isomer V and W are carboxylic acid with formula that can be written as C4H9COOH. They said given equation C4H9COOH reacts with sodium hydrogen carbonate. You just need to know this, and this is the equation correctly given. H2O and CO2, you need to just memorize. Okay, this is neutralization reaction. So salt plus water plus carbon dioxide. Now let's talk about the next part. It says isomer V has an asymmetric carbon atom. Now what does asymmetric carbon atom mean? So a carbon which is attached to four different groups on it. So it's an acid. So you draw the structure. Keep your focus onto this now, which I have written here. I'm going to use a different color pen. This is my acid. And if I highlight, you will not see any asymmetric carbon. Why not in this structure, if you just write the formula as it is, that like I'm just going to highlight the different hydrogen atoms. So if you see this one and this one, two same groups, so this is not asymmetric. This is also not asymmetric because there are two different same groups. Not asymmetric, not asymmetric. You need all four different groups. So what I will do is I will remove this methyl group and I will attach it to a different part of the chain to make an asymmetric carbon atom. So I'll move this to the second carbon atom. If you see this second structure I have drawn, and I left everything else as it is. So again, this will have two hydrogen here and hydrogen here, so not asymmetric. There are two methyl groups, one methyl group here, one methyl group here, one hydrogen and one this of the group here, but these two are matching, so that's why this cannot, this is and this is are same, so not asymmetric. This carbon has got these two same, so not asymmetric. Okay, so therefore this is not possible. This is also not possible. So if I just now talk about the third structure, I just moved, what I simply did is that I moved this methyl group not on the second carbon but on the first carbon just after the alcohol. So I moved it here. Now if you see, I put this hydrogen there. I'm just going to change the color to this. Yeah, this here. So same, not symmetric. This carbon is not asymmetric. But this one, if you see, now I'm going to highlight the four different groups. One, two, three, and this one. Whole fourth group is going to be this one. So now this carbon is my asymmetric carbon, and this is the structure of my compound. Okay, now let's talk about the next question. Okay, which is next part, which is isomer W. It says, I'm going to read this and highlight. Isomer W has four peaks in its NMR spectrum. Okay, deduce the structure of W. Now, four peaks mean it must have four different environment of carbon. That's the rule. Okay, so let's write down. They also asked you to deduce the integration ratio. Okay, so let's look at this. I drew this first structure. Let's say this is my first structure of the alcohol, and you want the four different hydrogen environment. Here you have three, here you have two, 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 and one. So you will have one environment, two, three, four, five. So this is not possible. Okay, let's look at the second structure. What I simply did was I moved one methyl group over here, and I wrote CH3C, and then I put the methyl group here, then CH2COOH. Now if you see, if I move this methyl group on the second carbon, I got these two methyl groups with the same um, same environment. So I would have one peak for these two. So these two will give me one peak. This will give me because there is hydrogen here. So this will give me second peak, and this will give me third peak, and this will give me fourth peak. So this likely to be the structure, but I'm going to draw one more by moving the methyl group, the carbon just after this carbons, to see what we get. Now if you do this, a totally different five environment you will see. One, two, three, four, and this is also different. So my correct structure will be this and not the other two. I hope this is making sense. Now I'm going to read or do the last one, which is this question. It says here, isomer X isomer X has three singlets. I'm just going to rub that off so that we can see it clearly. Yeah, three singlets with integration ratio of 1:3:6 in HNMR spectrum. Deduce the structure. So we know the formula. We don't know, it's not an acid. Now we just need to deduce the formula with this information. They only gave you the integration ratio here, and they said just work out the structure of this. So how do we approach? So we use the integration ratios. I'm going to write the integration ratio over here. Okay, so the integration ratio, I'm going to write here C. So the structure is, sorry, formula is C5H10O2. Okay, now integration ratio is given as 1:3:6, and you do not have any other clue about this question. Okay, so what we will do, use the integration ratio to work out. So we know the total number of, if you add all of these together, the total hydrogen you will have will be equals to 10, because 6 plus 3 equals 3, 6 plus 3 plus 1 equals 10, and that's what you have in the formula. So the ratio that they have given you is the actual number of hydrogen. Okay, so that's sorted. So what do you think this first, the integration ratio 1, meaning in this environment you only have only one hydrogen present on this carbon. Okay, that is true, that we know. But what could be then the only groups that you can have which can have one hydrogen in one particular environment are either OH or COOH or CH. Now possibility, this is least because they use that COOH in the top two, X and Y, I think the other two isomers. But these two could be the possibilities, and we are going to stick to OH functional group. Okay, so we consider it as an OH. Now think about these 6 carbon atoms. So we just decided that there is OH definitely, but this 6 carbon atom, you can have two. If you think very carefully, you can have one carbon, one methyl group which is attached to one carbon, and there should be one more methyl group, and this will give you 6 carbon atoms with the same environment, giving you integration ratio of 6. Okay, and this, remember one more very important thing they said, that this is causing 3 singlets. This is causing 3 singlets, meaning they are not splitting by each other. Okay, so peaks are not splitting, they are all singlet. Okay, so you have got 6 hydrogen atoms, but the peak is just single. It must be very long peak because there are 6 hydrogen atoms. Okay, so we got this 6 sorted so far. Now let's talk about this 3. How did you get this 3, or what could have caused 3? This is the peak with this hydrogen, this 6 hydrogen atoms, and a peak with one hydrogen atom could be like this. But for this one, what do we need to think of is that it could be because hydrogen CH3, and this must be next to a carbon which does not have any hydrogen, which could be carbonyl group, if that makes sense. So what I said here is that this is my CH3, which is giving you this integration ratio, but this will be having only one single peak because question says all 3 peaks are singlet. That means the neighbor, this carbon, should not have any hydrogen on it, which is not splitting at all that peak. So carbonyl could be one of them because I have 2 oxygen in the formula that I need to account for. So if you add all of these structures together now, one by one, see what you can make. So CH3, CO, then COH, then CH3, CH3. Now, if you see, are we accounting for what we have written on the top? So you have got this one peak for 3 hydrogen atoms, but next to the carbon doesn't have any hydrogen, so no split. Okay, these 6, no split because on the next carbon you do not have any hydrogen to split it. Then this by itself is just one single peak, it's OH. Okay, so the structure will be 3 dash hydroxy dash 3 dash methyl butane to own your structure. Okay, I hope this helped. To let me know if you do not understand anything and you want me to explain again. Thank you very much.